min-max optimization for linear and quadratic functions. First thing we talk about is what's a linear equation. So a linear function is f of x equals mx plus b. B. There. So a linear function, linear means line, so it's just going to be something like this or something like this. Linear functions, because they're straight lines, there's no maximum point and no min. So there's no way you're going to maximize or minimize a linear function across all x values. If you reduce it to some x values, you can. That's not going to happen for us here. So it leaves us with the quadratic function. F of x equals ax squared plus bx plus c. Now, a quadratic function is a parabola. And these, they can actually open in any direction, but for us in college algebra, we keep it simple. We open up and we open down. So this one opens down right here. This one opens up. Now, if you open down right here at the top, you have a maximum point. If you open up right here at the bottom, the minimum point. And as discussed when you graphed parabolas, is you can tell whether a parabola opens up or down by the A right here. If A is less than 0, then you're going to open down. So you're going to have a maximum. If A is greater than 0, you're going to have a minimum. All right. So in this section of this chapter, really we're going to be dealing with linear quadratic functions, which means, are there other functions out there that have minimums and maximums? Yes, they are. The quadratic function is the easiest function to find minimums and maximums for. Any other function, we'll probably go into calculus to deal with that, and this is an algebra class, so I'm not going to touch that. So min-max optimization problems, linear functions aren't going to give me anything. It means I have to have a quadratic function. So our goal is to create or find or be given a quadratic function we can either maximize or minimize. So look at an example here. Amongst all the rectangles that have a perimeter of 60, find the dimensions of the one whose, should say, whose, that should be area, is largest. So you look at a rectangle, you have length and width. Perimeter is twice the width plus twice the length. An area, right, for area is length times width. The only number we know is 60. P has to be 60. So if I look at this, here's my rectangle. Let's just call this width here x. If the width here is x, then the width here has to be also x. That means length is what's left over. So what do you have? We know the perimeter is 60. I have 2 x's plus 2 l's. If I solve for L, I know how long it is. So minus 2x minus 2x. 60 minus 2x plus 2L. Divided everything by 2. L, actually, that gives us 30 minus x equals L. So drag that up. There we go. This is 30 minus x. So our area, right? Area up here area is length times width. With 30 minus x times x. Or area, in fact, you're going to call it area of x because the area depends on x. It's the only variable in there. You multiply this out, you're going to get 30x minus x squared. Or a of x equals minus x squared plus 30x. This is our area. Now, if you recall, right? Let's go up here real quick. Fx equals ax squared plus bx plus c. Remember, it's all about this a. A tells me whether a minimum or maximum. So here, all right, a is minus 1, which is less than 0, so open down. So we have maximum. And if you go back and look, right, whose area is largest, that's a maximum. So we're on the right track. So all we need to do is find the coordinates of the vertex, right? Coordinates of a vertex for is x coordinate of the vertex of a parabola is x equals negative b over 2a. So in our case, a is minus 1, which is right here, and b is 30. So x equals minus b, so minus 30 over 2 times a, which is minus 1. And minus 30 divided by minus 2. X equals 15. Now 15 is the width that will maximize area. So let's put a little box in it. And like all word problems, you want to check yourself real quick. Come back up here to the original problem. Find the dimensions, right? I spelled dimensions wrong too. Find the dimensions, which means I want length and I want width. Well, length is right there. So L is going to be 30 minus 15 equals 15. So the dimensions that maximize the area of the rectangle is a square. All right. Let me know if you have questions on that. One more example I want to talk about. I'm not actually going to do this problem. We'll look at it though. All right. So among the pairs of numbers with a sum of 238, find the pairs whose product is a maximum. So I have two numbers, right? And for simplicity, we'll call it first number and the second number. And we have no idea what they are, right? Well, this is algebra, so we're going to make it trivial. Say, okay, the first number is x, right? X can be anything between 0 and 238. I have no idea what it is, right? But if x was 20, right? If x equals 20, then the second number would be 238 take away 20, or 218, right? So I don't know what it is, but suppose it's true. I'm just making this up, right? If x was 20, then it's going to be 238 take away x value of 20. So here it is. I don't know what x is, but x. This is x. The other number has to, first plus second number has to add to 238. So if I know that one number is x, then the other one has to be 238 plus, not plus, minus x. So, right? First number plus second number should equal 238. We look at that, right? X plus 238 minus x equals 238. These will actually add a 0, so 238 equals 238. And this stuff right here in this box, it's more for illustration. You don't actually need it for the problem. What you need to be able to understand is how I chose x and then how to get 238 minus x. And that's what this box here is for. Then it says, find the pairs whose product is a maximum, right? Product means multiplication. So product of first number times second number. So it's going to be x times 238 minus x. And I'll just call it a p here for product. And because it's all depending on x, I'm going to call it p of x. And you multiply this out, 238x minus x squared. Or p of x equals minus x squared plus 238x. And what is this? This is a quadratic equation, or parabola. And once you get to here, this problem is just like the previous problem we did. This is where I'm going to stop. You look for A, B, find the vertex. Let me know if you have any questions.